Hello, and welcome to this video tutorial. My name is Trevor. I'm currently a senior information and computer technology major at East Carolina University. I've created the following video as part of my senior capstone and hope that it enhances your understanding of Linux concepts. In this video, I will be giving an introduction to the Cron daemon and explaining how the scheduling utility operates. Let me begin by giving an overview of Cron and how it may be used. Cron is a scheduler that allows us to schedule commands or scripts to be run on a certain schedule. The schedule is set by us, the users or administrators, and can range from running a command every other second to running a command once per year. Execution of tasks is carried out by the Cron daemon. It's very customizable and a great way to automate tasks. Before I begin explaining Cron scheduling, it's important to make sure that SELinux is configured to disable protection for the Cron daemon if SELinux is set to enforcing on your system. To do so, simply execute this command. Advanced users may alternately disable protection by using the SELinux configurator system config SELinux. Here's a quick demo of how the command should be entered. After executing this command, wait until the blinking cursor becomes visible again in the terminal. Let's confirm that our changes are now in effect. To do so, use the get SEBool command shown here, which should return with a status of on. Here's a quick demo of how the command should be entered. As you may see, SELinux has been configured to allow the Cron daemon to run, and we're ready to proceed. Take a moment to look at these commands and note what each does. Let's make sure that the cron service is running and also make sure that it will automatically start when the system starts or reboots. To do this, we will issue the service cron start command to start the service. In order to make sure that the cron service always starts when our system does, we will issue the checkconfig cron on command. Take notice that we did not use start or stop, but we instead used on or off. So how do we configure cron schedule? With cron tab, a configuration file that contains a table specifying when various run parts will be run. Let me open up the cron tab file, which can be found in the /etc directory, and I'll explain further. The first thing you may notice about the file are the 5 initial columns with numbers or asterisks. This is how Cron knows when to run certain jobs. Unfortunately, the syntax for cron tab is not the same as our normal date syntax. Each of these lines are associated with either hourly, daily, weekly, or monthly cron jobs. Next to the schedule is the user account that will be executing the scripts. In this case, it is the root user. You may be wondering what runparts is and does, and I'll explain that in just a second, but first, let's move over to the last column, which lists a folder location. If we examine the folder's contents, you'll see that each folder contains various shell scripts. Runparts is a shell script that automatically runs everything that is not a directory within a folder. Given this, runparts will run every file in the /etc/cron.hourly folder on the first minute of every hour. How did I know when they would be run? By the indicated schedule in the first 5 columns. Let me explain how scheduling works. Displayed now are the first 5 columns from Cron tab. Starting from the left, the first column indicates on what minute of the hour a job will be executed. The values start at 0 for the start of the hour and go up to 59. The next column indicates what hour of the day the job will run. The values for hours range from 0 to 23, so be sure to use military time. The third column represents what date of the month the event should run on. Values can range from 1 to 31, or if the event should be run on every day of the month, use an asterisk. If you only want an event to run during a certain month, you should edit the 4th column, which indicates which month of the year a job should be run. The appropriate values for this field range from 1 to 12, or 3-letter abbreviations for the month. You may also use an asterisk for a job that will reoccur every month. Now, if you've picked up on the pattern here, you may be thinking that the next column will be years, but I'm sorry to tell you it's not. It actually indicates which day of the week you may want an event to occur on. You can indicate the desired date by using a 0 through 6, where 0 is Sunday. You may also use the first 3-letter abbreviations for each day. An asterisk may also be used if an event should occur daily. In addition to the general cron syntax, we may also define schedules that contain separate list items or date ranges. For example, if we wanted to create a new job that ran hourly on Monday, Wednesday, Friday, we can use a comma between the days to specify them. If we wanted to define a task that would only run on business days, we might find the hyphen useful to define this range of Monday through Friday. The last special character is a question mark. We would only use this if we are specifying a day of the month, such as the 15th, or a day of the week, say Wednesday. Since Wednesday doesn't necessarily fall on the 15th, we can only utilize one field at a time. If we want to run it on the 15th, a question mark will go in the place of the day of the week column, and vice versa. If you find yourself still having trouble with the scheduling syntax, you may opt to use special strings, which provide the same result as seen in the default cron tab. These strings are easy to use and can certainly improve the file's readability. Take a moment to review them. One last consideration to think about is the use of user access control. In the default system cron tab, the commands are executed as the root user. But what if we have a user who wants to run a nightly backup using cron? By default, the user has this ability. There are two key files that we use to configure access control of cron. By default, a blank text document called cron.deny also exists in the /exe folder. If we wanted to deny certain users, we would simply add their username to this file, one per line. But what if we wanted to deny access to all users except for certain ones? Easy. By creating the other file, cron.allow, in the /etc directory, and populating it with allowed users, we circumvent the cron.deny file. To put it simply, if a cron.allow file exists, the only users that can utilize cron are those that are named in this list. But be careful, if cron.allow exists and is blank, nobody will be able to use cron except root, who always has permissions. Since user access to cron can be confusing, let me go through a few scenarios and explain their outcomes. Firstly, if cron.allow exists with user entries, cron.deny doesn't matter. Only the users in cron.allow may use cron. In another situation, if cron.allow exists without user entries, cron.deny still doesn't matter, and nobody will be permitted to use cron. If cron.allow does not exist and cron.deny exists with user entries, everyone except for those users defined in cron.deny are permitted to use cron. If cron.allow does not exist and cron.deny does exist but is empty, everyone can use cron. This is the system default. And lastly, if neither cron.allow nor cron.deny exist, no users are permitted to use cron. This concludes the cron tutorial. I hope you have found this video beneficial, and I thank you for watching. Be sure to check out other Linux tutorial videos in our channel.